In this video I would like to introduce a very nice problem. Here is the Greece Mathematics Olympiad of 1997. So our goal, we are going to solve this following equation in integer numbers. Okay, so we have this following setup. We have number 13 is divided by x squared plus 1996 is divided by y squared equals z is divided by 1997. 1997 is representing the year of this Math Olympiad. Okay, so in fact this equation is not hard to solve. So the only thing we are going to concern about we are going to consider the negative and positive solutions due to this x squared and y squared. But unfortunately we don't have no symmetry here because x and y are working differently. Okay, the other nice thing here, z is independent variable. Okay, now let's go through this one. So without loss of generality, we have x and y and z is a solution, and also we have minus x minus y, z is a solution. Also we have x and minus y, z is a solution. Lastly we have minus x, y and z is a solution. Okay, we will have 4 pair of the solution. So we have, here is the following equation. We have 13 over x squared plus 1996 is divided by y squared equals z is divided by 1997. Now I'm simply going to cross the multiplication here by making x squared and y squared as a common denominator. So I get 13 here. I get 13 is multiplied by y squared plus 1996 is multiplied by x squared as a numerator is divided by x squared is multiplied by y squared equals z is divided by 1997, like this. Okay, now crossing the multiplication I get the following expression. I get 13 is multiplied by 1997 is multiplied by y squared plus this term is multiplied by this term, which is 1996 is multiplied by 1997 is multiplied by x squared equals x squared is multiplied by y squared is multiplied by z, like this. Okay, notice here, keep in mind x and y must be different than 0 because they are situated in the denominator. Okay, now which means x, y, z are the integers minus 0, and also z must be different than 0 because if you have z equals 0 but the left hand side of this equation is not 0, which means all of these variables x, y and z are excluded 0. Okay, as a solution. And also z must be positive because the left hand side of this equation is positive. Okay, so the second observation, z must be strictly superior than 0. Okay, of course x, y, it can be negative, it can be positive because we have this square. Okay, now since x, y and z are different than 0, we are going to divide both sides by x squared, y squared. So which means I get here 13 is multiplied by 1997 is divided y squared will be cancelled out. I will be left with x squared in denominator. Okay, for the second term I get x squared cancelled out from numerator. I get this one divided by y squared. 1996 is multiplied by 1997 is divided by y squared equals z. Z, we know z is a positive integer. Okay, integer. I don't want to put this z as this one because we don't want to mix z with the set of these integers. Okay, so since the right hand side of this equation is an integer, which means the left hand side of this equation must be an integer as well. But remember here, in order to get this, so which means this one is an integer. Also this one must be integer. Okay, but in order to have this one as an integer number, we must x equals one of these numbers. 13 or 1997. Especially 13 and 1997 are the prime numbers, okay? Which means one of these numbers must be equals x, okay? But this one is not going to happen because we have x square, which means we have 13 square here or 1997 square here, which is impossible because if you have 13 square here, I get cancelled out 13 from numerator, I will be left with 13 in denominator, which is impossible. It becomes not integer. The same thing, this, which means in order to get rid of this one and fix this issue, we are going to give x equals 1, okay? The only way to get integer, otherwise it's impossible, which means x must be equals to 1, of course minus or plus 1, okay, because we have a square. This argument follows similarly to the previous one, but the only difference here, 1996 equals 4 is multiplied by 499, like this, okay? In order to get square here, the only way to get integer, we must give y equals plus or minus 2, because 2 square or minus 2 square is giving us 4, which means it will be cancelled out with this 4, which is located in numerator, okay? So which means I have a solution. Now I get x equals plus or minus 1 and y equals plus or minus 2, like this. Now the only thing left now, z, we are going to determine z. I'm simply going to use the original equation by replacing x with number 1, y with number 2 here. So I will get 13 over 1 square, which is 1, plus 1996 over 4 equals z over 1997. So this term 13 plus 1994, 4 will be cancelled out as I said before. This 4 will cancel out because we have 1996 is 4 is multiplied by 499. 4 will be cancelled out. I will be left with 499 plus 13, which is 512. So I get 512 equals z over 1997, which means z equals 1997 is multiplied by 512 is 1,022,464. So now I'm going to expand these solutions and put them on the form of this pair of the solutions as I have here in the above statement. So I will get the first solution, x equals 1 corresponding with y equals 2. Z, I'm going to write z as z0 like this, with z equals z0 equals 1,022,464. okay. The second pair of the solution, I will get x equals minus 1, y equals minus 1 with z0 like this. The third pair of the solution, I get x equals minus 1 with y equals 2 with z0. Lastly, I get x equals 1 with y equals minus 2 with z0 like this. So here is the 4 pair of the solutions for this equation. So I have done with this video. If you have any question or suggestion, just put it in the comment section below. Don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.